Hello. Morning. We're gonna make a. Today we're gonna solve a simple problem, a very common problem people use for interviews. It's called Fizzbuzz. We're gonna solve it using a test-driven development approach. Test-driven development approach helps you drive your design, helps you decompose a problem by breaking it down into small tests that drive your implementation. And nothing simpler than starting with the tests and then driving your code. The problem is very common. It gives you a requirement to print the first 100 numbers, and those numbers are multiples of 3. The program should print the word fizz. Numbers are multiples of 5 should print the word fuzz, and for numbers that are multiples of the 5 and 3, we should get Fizzbuzz. So in pure TDD fashion, let's start with the test. And remember, the test should be very simple, and it's like, look at how many requirements I have. I have to print 100 numbers, I have to print fizz, I have to print those. Let's start with the smallest, simplest thing that comes to mind, which is the first number. And since I don't have a better name, prints the first number. So let's start with assertion. What would my expectation be? The first number should be 1. And now comes the part where actually I'm going to invoke the code that I want. But if we look at the project, I don't even have anything there, so that's fine. Like, we're going to drive our code. We're going to design how our code should look with the test. So I'm going to say I'm going to have a Fizzbuzz class, and it's going to have a read method. And the read method would receive 1 as parameter. Now, you know something here? The Fizzbuzz is red. Why? Because that class doesn't exist. So I'm gonna create that class right there in this package. Yep. Ooh, why don't you show it default? Okay, I guess. Actually, let me just show it. Create it manually. Create a new class. It's gonna be called Fizzbuzz. And that thing right there, the red squiggly, it's a failing test. It's a failing test from the compiler. The compiler is telling me, yeah, I can't even compile. The compiler helps you and makes tests for you if you want. Now the second failing test I have here is I don't have a read method in that class, so I'm going to create it. Atelier is going to help me. Atelier already figured out that the method should return a string and should receive an integer, and it's going to even provide a default implementation for me. So I'm going to just run it, see what I get. Now I have a failure. My test was expecting to get 1, but it got null. So how do I make this test pass? TDD has 3 different modes. The first mode is writing a test and make sure that that test fails. The second mode is making sure that that test pass, and that should be your focus. Making the test pass, committing things, making code duplicate, making the code ugly. You don't worry about that at this stage. Once you have your test passing, you focus on making the code better. So let's focus on making the test pass. So I'm just gonna hard code the result here. I'm gonna run it again, and voila, everything works. So now my test is passing. Let's go to the third step, removing the duplication. Where is the duplication here? And removing duplication means refactoring, making the code better, cleaner, etc. So do you notice this one from the right gets passed as a parameter, as an I parameter, and then this I, somehow this one that gets here as an integer gets returned as a string. I think it's safe to do this. Let's say string format. And if it's unsafe, I'll just revert it back the way it was. And voila. We have a test that works. Okay? Let's look at our requirements. We should print the numbers from 1 to 100. We'll worry about that later. We just need. I'm trying to figure out if the numbers are properly read, and I mind that it's easier to test specific numbers one by one than to test an array. And I may be wrong, and you may have a different idea how to implement this. The result may end up being similar. The important thing is to let your tests drive. So I think that testing one number at a time is easier. So let's just test a second number. Let's say what should happen for 2. And it passes. So why it passes? Because the implementation I got out of refactoring and removing duplication with just my single first test helped me not need this second test. So I'm gonna delete it. Let's move on to the other requirement. It should print fizz for the numbers of the multiples of 3. But before I do that, I'm gonna rename this test. Prints the first number. It doesn't make sense. So I'm gonna rename it to prints regular numbers. Okay. So now let's create another test. Test. Oops. Can't type. Public void prints fizz for multiples of 3. And I'm gonna copy this a little bit. Oops, copy. So when I pass you 3, I should get what? Fizz. When I run this test, it should fail. I'll have a failing test. There's a way to show all the tests here. There we go. So we can see everything that passes and only the ones that fail. So I'm going to go and make that test pass. So how do I make this test pass? The smallest possible thing that comes to mind is saying if I is equal to 3, it's going to return fizz. Let's run it. There we go. That works. But we know that this is not correct yet. So how do we drive this implementation? Let's add another test. Let's say when I pass you 6, you should also print fizz. There we go. We are failing. The test says, hey, I was expecting 6, and guess what? I got fizz. So let's make this pass. How do I make this pass? I can just say if I is greater or equal than 3, I should get fizz. Okay. So once more, I cheated, but this is valid. This is an error that you could get out of a merge conflict. You could have forgotten something, and you can end up in this situation where your tests are not appropriate for the implementation that you want. And this is the idea of test-driven development. You're gonna drive your code. You won't write your code and then write the test. Your test would help you lock down and write exactly what you wanted. So let's add a separate test. So I think that this is the time where we can enhance the first test, and we can say, hey, I want you to print 4 for 4. And now, even though the second test is working, the first test started to fail, and now we're getting, hey, expected 4, but I got fizz. So how do I make this pass? Well, I think it's time for me to say only do it for the multiples of 3. There we go. Now, the thing I want to cover here, notice how I'm creating multiple assertions per test. Usually a test you have a single assertion. In this case, I think it's easy to know when a test fails, when one of these tests fails. Why? Your mileage may vary. I try to aim for at most one assertion per test. So let's move on to the other requirement. Multiples of 5 should print boss. So I'm gonna copy this. Say print boss for multiples of 5. So I'm gonna say here, I think I can do this. No, boss. Fizzbuzz read 4. I want you to do 5 and I want you to do 10. And I won't try to cheat here because I know this is practically the same as before, and I can cheat all the way, but with my requirements. But I know we're gonna end up with the same, so I took a larger step. The important thing is get a failing test and then making it pass. So I'm gonna do this here. Say if I is multiple of 5, I want you to run boss. Okay? So when I run it, to pass. Okay, now the other requirement. So multiples of 3 print fizz. I think this is done. Multiples of 5 print boss print done. Now notice how I'm doing this. I converted my requirement sort of a checklist. One driving idea behind test-driven development is not to think of too many things at once. So if something comes to mind, like write a program that prints the numbers from 1 to 100, or make my implementation functional, those sort of items, that's something that you're not working on right now, throw it into to do and then start working through it. And eventually, you won't forget anything, but you won't have to keep all that in your head, because when you keep things in your head, you forget things. So let's go to the other requirement, prints Fizzbuzz for the multiples of 5 and 3. So that should be really the name, prints Fizzbuzz for multiples of 5 and 3. I'm gonna say, hey, I want you to print Fizzbuzz for 15. I think this is the first multiple of 5 and 3. So when I run it in Fizzbuzz, but you got both, so I'm gonna say when I is equal to 15. Come on, do I really have to cheat now? Try to do this. I don't know, sometimes I like to go back and take small steps. So now this works, but this implementation is not complete, so let's add another multiple of 15, or multiple of 5 and 3, which is 30. Okay, print multiple of 5 and 3, Fizzbuzz. I can do the same as I did before, I just put an add there, or I can log it out a little bit and say 15. So now I have something that prints me Fizzbuzz for multiples of 15, I'm in boss for multiples of 5, and Fizz for multiples of 3, and then prints the numbers. Now we're not done. We don't have a problem, and we don't have to print a range of numbers. So testing out printing is not super easy, because I imagine we're gonna print to the console. That's not simple enough. Let me try to get that out of the way and try to make my Fizzbuzz class return an array of numbers. And the other thing is, testing 100 numbers may be tricky, so let's make that parameterizable. So if my Fizzbuzz class can return a range of numbers, and I know that works, I can safely assume that my Fizzbuzz class somebody else can print them later, and I can return 100. So once more, let's start with a test. So I'm going to say test public void returns a range of numbers. So when I say and I'm gonna say string actual range, and what would this actual range should be? It would be Fizzbuzz dot range up to 5. Those of you that saw the beginning would know that this is the failing test. That this is the compiler telling me, hey, I don't know what you're talking about. I don't know what range is, so I'm gonna let IntelliJ help me. Let's create a method range that returns an array of strings and receive the count or numbers. Initially, the range will be empty. Okay, so this will be my first test. Now let's start writing in small increments. What would, if I tell my Fizzbuzz calculator, my Fizzbuzz class, to give me a range of 5 numbers? I think my first test will be actual range dot size dot length, and I'm gonna say you should have 5 elements. Let's see what we get. Okay, so I was expecting 5, I got 0, so I think it's safe to say now that I want you to return a new array of 5 elements here. Let's run it. Okay, my test is passing. Now, what comes next? Let's validate that each element of that array is what I want it to be. Now let's move my face a little bit to the left so you can see my test. So I'm gonna say ser equal 1 what? My actual range is 0. Let's run it. Okay, I got 1, but I was expecting, I got no, but I was expecting 1, so let's start making that pass. So let's create a variable for this result. Let's say result in 0 is going to be 1. Okay, once more, just making the test pass, nothing fancy. Okay, so my test is passing. Let's continue triangulating the behavior I want. So my second number would be 2. Okay, I was expecting no, but I got 2, but I got no, so I'm gonna just put here 2. Do you guys notice something tedious about this? Would I have to? I don't want to have to actually write 5 test cases. So let's, with this test here, let's try to make it a little bit smarter. Let's try to make my test easier to write. So I'm gonna say for int I equals 0, while I smaller than 5, I plus plus. So I'm gonna create a variable calling the expected item. And what would the expectation be? It would be easy. I know that my Fizzbuzz read method works, so I'm gonna say yeah, I plus plus, I plus 1. So I'm gonna read the ith number using Fizzbuzz, and then the actual number. I'm gonna say assert equals what? Expectation of what? Of my actual range in I. So I'm saying my range should contain elements that are equals to what Fizzbuzz says. So, and notice how I left the other tests that we're passing. I'm gonna remove line 35 and 37 at this point because they're being tested, but let's see what our failure was. So return selection number. I was expecting Fizz, but I got no. Where? Now, this test is not super helpful. This assertion, it's hard to know what was I trying to test. So luckily I can add a message that would help me understand why the test failed. So, and this is the problem when you have multiple assertions in a test. In this case, we're gonna have 5. What happens? So I can say expected, index, and I can just string format this. it's gonna be a number. BI. Let me move this to the left so we don't have to wrap this line. Let's see how the failure looks like now. So my index is 2. That means the third number should have been Fizz, but I got no. And clearly, if we look at the implementation on the left, we see that we're not returning a third number. So I think that we can say here, hey, I want you to return Fizz. And let's see if that make the test pass. Okay, but now we have another failure for the fourth number. I think at this point, I don't want to waste more time faking it, so I'm just gonna say for int I equals 0 while I smaller than count I plus plus. I just say result in I will be equals to read in I plus 1. Let's sure that it works. Okay, so I got my test passing. Let me run it once more to make sure that it passed. Now, am I cheating here? Am I using, because I'm using the same implementation in my code and my test. Notice how they look very, I don't need this test anymore. These two assertions there. I don't think I'm cheating because I started with my test. I said, I know that Fizzbuzz read works, and I'm testing it in the above tests. So rather than having to duplicate all this code and all these tests, I can just say that is my expectation. And so I'm saying for each element from 1 to the range, you should return what I want. And notice how I had the 5 multiple times here, so I can safely extract that as a content and change it. So let's extract that as a replace three occurrences. Count, and it's supposed to be 5. Let's make it smarter. Let's make it 100 or 10, and my test should pass. So now that we have our test passing and we know that this returns a bunch of numbers, I don't particularly like this style of writing it. I like to write it more in a functional approach where we don't have to mutate the result variable. And this is a very textbook example of that. So I'm going to create an int stream range close, and my range is going to start at 1 and it's going to end at count. And for each element in that range, which will be 1, 2, 3, 4, 5, I'm going to call my read method. So I'm going to call fizzbuzz.read, and then I'm going to return an array with that, and the array will be a string array new. Let's see if this refactoring worked. Missing return statement, of course. If I don't return, the compiler jails. Okay, so my implementation is correct, and notice how now my test diverged from what my code looked like before, but my code still does the same, and it does it in a more concise and less intrusive way. It's saying fairly right, saying, hey, create a range of numbers from 1 to 5, or whatever number you pass me, and then for each of those numbers, I want you to read what would the Fizzbuzz implementation be, and they just make it a string. So I think it's safe to say that we completed. Ooh, no, we are not completed. We're missing writing a program. So now that we have this done, I mean, a program would be very simple. It would be just making this class public, adding a static method to it, static void main, string arcs. And what would this program look like? It would say Fizzbuzz the range up to 100. I'm gonna make that a string. I'm gonna say for each element there, I'm gonna print it. So I'm gonna say for each element, it's gonna be system out print line. And I'm gonna run this program, and it should work. There we go. We have a program that prints the numbers 1, 2, 3, Fizzbuzz. We want to make it up to 1000. Very easy. Just changing this number. It's tested. Now the missing steps will be making sure that the actual printing gets invoked. Oh, you can't see it. Sorry. Let me move my face here. It's alright. Stupid face. So notice how simple my program was. I didn't have to do all of the logics, all of this definition and figuring out what to print. My program became a one-liner practically. And that's what we aim to. We want to make sure that the code that is hard to test, the code that is outside of our control, is very slim. It's outside of the boundaries of our application. I think this concludes our screencast. In the next time, we'll try to test the actual input and output of the program.